Record. Hi, ma'am. This is T. Kushi from ITA, and my roll number is 37. And my tech talk topic for ADE is light emitting diode. So, what is LED? A light emitting diode is a semiconductor device that emits light when an electric current flows through it. When current passes through an LED, the electrons recombine with the holes emitting light in the process. LEDs allow the current to flow in the forward direction and blocks the current in the reverse direction. Light emitting diodes are heavily doped PN junctions. Based on the semiconductor material used and the amount of doping, an LED will emit a colored light at a particular spectral wavelength when forward biased. As shown in the figure, an LED is encapsulated with a transparent cover so that emitted light can come out. So from this slide, you have to make sure about some of the important points, that a light emitting diode, that is LED, it is made up of a semiconductor device and it only works when the current flows through it. And LED is always in forward direction, that is it is always forward biased, and the current is allowed to flow in only forward direction, and the current which is flowing in the backward or reverse direction is blocked. And light emitting diodes are nothing but these are heavily doped PN junction diodes. So PN junction diodes means nothing but P-type semiconductor and N-type semiconductor. And as you all know, P-type semiconductors have majority of holes and minority of electrons, and N-type semiconductors have majority of electrons and minority of holes. These PN junction diodes are always connected in forward bias. That is, P-type semiconductor is connected to the positive terminal of the battery, and N-type semiconductor is always connected to the negative terminal of the battery. So this is called as forward biasing. And according to the amount of doping, LED can emit different lights of different colors at a particular spectral wavelength. So as shown in the figure, an LED is encapsulated with a transparent cover. So LED has a transparent cover upon it so that it can emit light, and light can be seen or light can be visible. So the light emitting diode, or LED as it is more commonly called, is basically just a specialized type of diode, as they have very similar electrical characteristics to a PN junction diode. This means that an LED will pass current in its forward direction but blocks the flow of current in the reverse direction. Light emitting diodes are made from a very thin layer of fairly heavily doped semiconductor material, and depending on the semiconductor material used and the amount of doping, when a forward biased LED will emit a colored light at a particular spectral wavelength. So from this slide, we have got a point that LED is similar to a diode, but it has some more special characteristics making it different from the diode. When the diode is forward biased, electrons from the semiconductor's conduction band recombines with the holes from the valence band, releasing sufficient energy to produce photons which emit a monochromatic, that is single color of light. Because of this thin layer, a reasonable number of these photons can leave the junction and radiate away, producing a colored light output. So from this paragraph, we are getting a point that the recombination of holes and electrons in the conduction band and valence band, some amount of energy is radiated or released in the form of photons. These photons are nothing but small packets of energy or anything, or light energy. So this energy radiated away will produce a color. So this color is nothing but seen as light output. Then we can say that when operated in the forward bias direction, light emitting diodes are semiconductor devices that convert electrical energy to light energy. So LEDs always convert light energy, or I mean electrical energy to light energy. You also know there is another type of diode called as photodiode. So a photodiode converts light energy into electrical energy, whereas light emitting diode, that is LED, converts electrical energy into light energy. The construction of light emitting diode is very different from that of a normal signal diode. The PN junction of an LED is surrounded by a transparent, hard plastic epoxy resin hemispherical shaped shell or body which protects the LED from both vibrations and shocks. Surprisingly, an LED junction does not actually emit light that much, so that epoxy resin body is constructed in such a way that the photons of light emitted by the junction are reflected away from the surrounding substrate base to which the diode is attached and are focused upwards through the domed top of the LED, which itself acts like a lens concentrating the amount of light. This is why the emitted light appears to be brightest at the top of the LED. However, not all LEDs are made with a hemispherical shaped dome for their epoxy shell. Some induction LEDs have a rectangular or cylindrical shaped constructions that has a flat surface on the top, or their body is shaped into a bar or an arrow. Generally, all LEDs are manufactured with two legs protruding from the bottom of the body. Also, nearly all modern light emitting diodes have their cathode terminal identified by either a notch or a flat spot on the body, or by the cathode lead being shorter than the other, as the anode lead is longer than the cathode. So, as you all know, light emitting diode also has cathode part, that is negative terminal, and anode part, that is positive terminal. So, how to differentiate cathode and anode part? So, generally, first thing to identify is by their notch or a flat spot. If this is not there, then by the length of the cathode lead, the shorter the length, which one is shorter, that is cathode, and the longer one is the anode. Unlike normal incandescent lamps and bulbs, which generate large amount of heat when illuminated, the light emitting diode produces a cold generation of light, which leads to high efficiencies than the normal light bulb, because of the generated energy radiates away within the visible spectrum. Because LEDs are solid state devices, they can be extremely small and durable and provide much longer life than normal light sources. So in this picture, you can see the light emitting diodes. How is it represented in a circuit, and how does it look practically? So you can also know that LEDs are available in different colors like yellow, red, blue, white, etc. And LED's structure or figure is same that of a diode. So this is a simple LED circuit. So this circuit consists of resistor, LED, and a voltage supply. So now let us know, how does an LED work? When the diode is forward biased, what is forward biased? In forward bias, the P-type semiconductor is connected to the positive terminal of the battery, and N-type semiconductor is connected to the negative terminal of the battery, and always the current is allowed to flow in the forward direction, and the current flow in the backward direction or reverse direction is always blocked in an LED. So when the diode is forward biased, the minority electrons are sent from P to N junction, while the minority holes are sent from N to P junction. At the boundary, the concentration of minority carriers increases. The excess minority carriers at the junction recombine with the majority charge carriers. So as you can see the circuit in the picture, the blue part is nothing but the P-type semiconductor, and the N-type semiconductor is denoted in the yellow part, and holes are that white small circular regions, and red circular regions are electrons. So the recombinations of electrons and holes takes place when the current flows through the circuit in the forward direction. So as you can see that due to this recombinations, there is a Fermi level band gap. This band gap is known as Fermi level. The energy is released in the form of photons on recombination. In standard diodes, the energy is released in the form of heat, but in light emitting diodes, the energy is released in the form of photons. We call this phenomena as electroluminescence. Electroluminescence is an optical phenomena and an electrical phenomena where a material emits light in response to an electrical current passed through it. As the forward voltage increases, the intensity of the light increases and reaches to the maximum. So here in this picture, you can see the light emitting diode, that is VI characteristics of a light emitting diode. So when you're drawing a graph of VI characteristics of a light emitting diode, always take voltage on x-axis and current on y-axis, as you can see in the picture, and you can mark the graph depending upon the intensities of light. Before a light emitting diode can emit any form of light, it needs a current to flow through it. As it is a current dependent device with their light output intensity being directly proportional to the forward current flowing through the LED. As the LED is to be connected in a forward bias condition across a power supply, it should be current limited using a series resistor to protect it from excessive current flow. So, never connect an LED directly to a battery or a power supply, as it will be destroyed almost instantly because too much current will pass through and burn it out. So from the table above, we can see that each LED has its own forward voltage drop across the PN junction, and this parameter, which is determined by the semiconductor material used, is the forward voltage drop for a specified amount of forward conduction current, typically forward current of 2 milliamperes. In most cases, LEDs are operated from a low voltage DC supply with a series resistor used to limit the forward current to a safe value from say 5 milliampere for a simple LED indicator to a 30 milliampere or more, where a high brightness light output is needed. So there are many types of light emitting diodes, that is gallium arsenide, which is infrared in color, gallium arsenide phosphide, which is red to infrared or orange in color, aluminum gallium arsenide phosphide, which is high brightness red or orange red colored, and gallium phosphide, which is red, yellow, and green in color. Aluminum gallium phosphide, which is green in color, gallium nitride, which is green and emerald green in color, gallium indium nitride, which is near to ultraviolet colors, that is bluish green and blue in colors, silicon carbide, which is blue as a substrate, zinc selenide, which is blue in color, and aluminum gallium nitride, which is ultraviolet in region. So let us know about the uses of LED. LED finds applications in various fields, including optical communications, alarms, security systems, remote controlled operations, robotics, etc. It finds usage in many areas because of its long-lasting capability, low power requirements, swift response time, and fast switching capabilities. Below are a few standards of LED uses. It is used for TV backlighting, used in displays, used in automotives, LEDs used in dimming of lights as well. Types of LED. Below is a list of different types of LEDs that are designed using semiconductors: miniature LEDs, high power LEDs, flash LED, bi and tricolor LEDs, red, green, blue LEDs, alphanumeric LEDs, and lightning LEDs. So what are the advantages of LEDs over incandescent power lamps? LEDs consume less power and they require low operational voltage. Now warm-up time is needed. No warm-up time is needed for LEDs. The emitted light is monochromatic, that is single colored. They exhibit long life and ruggedness. So coming to the conclusion, what all we have learned in this presentation, we will conclude what are all the important points. We'll revise it once again. So a light emitting diode converts electrical energy to light energy, and a light emitting diode is a type of special diode whose PN junction is made from a compound semiconductor. The LED compresses of a heavily doped semiconductor and has a very thin layer of PN junction. The forward biased LED enables the electrons in the conduction band to recombine with the holes in the valence band. In doing so, the electrons release the energy in the form of photons or light. The color emitted by the photons is dependent on the semiconductor compound used in the LED, and its intensity is dependent on the forward biasing current. The wavelength of the emitted color lies in the visible or invisible light spectrum. The series resistance is used essentially to avoid damaging the LEDs, and the value of series resistance requires to be calculated depending on the LED type, number of LEDs, and their series or parallel configuration. The LEDs are available in various colors. The monochromatic colors are widely used and cheap, whereas bi and multicolor LEDs are also available but comparatively costly. The LED applications include induction purposes, displays, televisions, and large advertisement displays, etc. So the main point is LED converts electrical energy into light energy, and in LED is always applied in forward biasing, and the current is always allowed to move in forward direction, and the current which is moving in reverse direction is always blocked. And coming to LEDs, you have different LEDs, different varieties of LEDs which emit different lights depending upon the particular spectral wavelength. And you will have bicolor and multicolor LEDs also. These are also available, but these are comparatively costly. But whereas monochromatic LEDs are widely used and they are cheap, and because of its high capabilities, and it does not require warm-up time and all, it is mostly used. Yeah, it is mostly used, and it has many advantages. So hope you all understood about the LEDs, the working of the LEDs, and the advantages of LEDs, and what are the types of LEDs used. Thank you so much.